All right, so our objective for today is you can solve exponential equations algebraically. And we're going to have to be able to use the exponent properties that we did yesterday. So if we look at our prior knowledge here, it says write each rational number as a power of 4. So for all of these, we're going to go like 4 to the power of something. 4 to the power of something. And 4 to the power of something. Okay, so how can I get a 16 with the power of 4? 4 to the second power, right? 4 squared is 16. And what about the 1 over 64? Negative 3, you said? Okay, good. And it's negative because we have the fraction, right? So our reciprocal power, our reciprocal property is we have 1 over the positive power, so 1 over 4 cubed. But if you move it to the reciprocal, and the numerator becomes negative. And our last one, 4 to the what power, gives us 1. I heard one person. What is it? 0. Good. 4 to the 0 power. All right, so in today's concept, we have the exponential property of equality. Can be used to solve exponential equations where both sides of the equation can be written as a power of the same base. And then that'll give us the exponential property of equality. So this says if you have the same base raised to different exponents, then my two exponents will equal each other. Okay? So if I have the same base with different exponents, then my two exponents can equal each other. And then we have steps to solve exponential equations. We're going to first write the equation with a single term on each side. And then you're going to write each term as a power using the same base. And then you're going to use the exponential property of equality to set the exponents equal. And then you're going to solve this equation and then state the solution to the exponential equation. All right, so if we look at our first example here, it says solve the equation. We're being asked to solve for x. And so first step 1 is get one term on each side. So I do have only one term on each side. I don't have pluses or minuses on either side. So then here, my next thing to do is write my numbers with the same base. Because this is a 4 right here, I want to check, can I get 16 with a base of 4? Yes, right? So I want to change my 16 to a base of 4. This is going to be 4 to the x power, and 16 can be rewritten as 4 to the what power? Second power. Good. And then notice my bases are the same, so therefore my exponential property of equality says I can make my two exponents equal to each other. This is going to be x is equal to 2 now. And I can only do that if the base is the same. And it does. And then if you have anything else attached to it, then you would have to solve for x. But in this case, I already have x by itself equal to 2. So my answer is x equals 2. Okay. All right, let's go ahead and look at our next example. Our next example is going to have fractions, I believe. Yes. So let's look at this one here. Please write down this example. We have 5 to the x equals 1 over 125. Okay, so first I want to make sure we have a single term. This 5 to the x, that's one term, and this is one term. I don't have any pluses or minuses, so we're good there. Then my next thing is to write this as a power of the same base. Well, 5 is prime, so I can't do anything to the 5. But this 1 over 125, can I get this into a base of 5? Yes. What is that going to be? 5 to the 5 to the negative third, right? Because this is 5 to the x equals, I'm going to just write this step. You don't have to write this step, but this is 1 over 5 to the third power. And then, excuse me, that 5 to the third is going to become a negative exponent. This is 5 to the x equals 5 to the negative 3. And you guys can skip that red step. I'm just writing it out so you guys understand where the negative is coming from. All right, then you want to... I found this on the web. Sorry. And then you want to check, do you have the same base? Yes, we have the same base. That means our two exponents can equal each other. Now I have x equals negative 3. And I have x by itself, so that's my final answer. X equals negative 3. So for our next example, we have 36 to the x is equal to 6. All right, so this one is a little bit different because notice that my 6 is the smaller number, is not attached to the x. So this time I still want to do the same thing. I still want them to have the same base. So 6, I can't really break it up into smaller powers because 2 squared is 4, 2 cubed is 8. So I can't get 6 from a base of 2. 3 squared gives me 9. So I can't break up 6, right? So this one has to be a base of 6. Can I change my 36 into a base of 6? Yes, that's going to be 6 to the what power? 6 to the second power. But then I still have that x right there, right? So this is 6 squared to the x power is equal to 6 to the what power? Gives me 6. First power. Good. 6 to the first power. So now I have the same base. And remember, this is my exponent rules, a power to a power. What do I do with these, with the 2 and the x? Do I add them, multiply them, subtract them? What do I do? If it's a power to a power. Does anybody remember? Power to a power? So, like if I have x to the m times x to the n, what's my exponent rule? Add them, right? M plus n. And then my division, if it was x to the m divided by x to the n, what's my rule? Subtract m minus n. And if I had x to the m raised to the nth power, do you guys remember what to do? Multiply. This is supposed to be m times n. And so because in this case this is a power to a power, this means I multiply those two together. So it's just going to be 2x. And then that's going to equal 1 because my bases are the same. So then this is going to be 2x is equal to 1. This is my side note. You don't really need this here, but I have it there just as a reminder, as our side note. Okay, and then in this case, I don't have x by itself. The other examples that we did, we had x by itself, so we were basically done. But in this case, I have a 2 attached to the x, so I have to get rid of the 2. What can we do to get rid of the 2? Divide by 2 on each side, and that gives us x is equal to 1/2. And that's our final answer for this one. All right, let's look at another one that also has fractions. Solve the equation. Go ahead and copy this one. We have 1 over 7 raised to the x power equals 49. All right, in this case, I have a 7. 7 is prime, so I for sure am going to have to use the base of 7, right? Can I write 49 as the base of 7 also? Yes. So I can use the base of 7. This is going to be, well, yes, this is going to be 7 to the second power, but my fraction is going to be what? 7 to the negative. Good. Because remember, that's 7 to the first power, and I want it to be as a base of 7, so I don't want a fraction, so I have to flip it to the numerator. And then if I flip it to the numerator, it becomes negative. So 7 to the negative 1 raised to the x power. And again, now I have the same base. So now my exponents can equal. And that negative 1 to the x power, that means you're just going to multiply them. So that's just going to be negative 1 times x equals 2. And then what can we do to solve for x? Divide by negative 1 on each side. So x is going to equal what? What's 2 divided by negative 1? Negative 2. My answer is x equals negative 2. All right. So on this one, we have 4 to the x is equal to 32. Remember, we want to get them in the same base. But what are my powers of 4? I have 4 to the first power is 4. 4 squared is what? 16. And 4 to the third power was 64. Can I get a 32 with the base of 4? No. That means I'm going to have to use base of 2 because the only other thing I can change 4 into is a base of 2, right? So in this case, I can't use the base of 4, but if I look at the bases for 2, that's 2 to the first is 2. 2 squared is what? 4. 2 cubed is 8. 2 to the fourth is 16. And 2 to the fifth is 32. So there's my 32, and here's my 4. I have both of them can be written as a base of 2, right? So then I need my 4 as the base of 2. 4 is my 2 squared raised to the second power is equal to my 32 is my 2 to the fifth. So 2 to the fifth power. And now my exponents have the same base. Sorry, my equation has the same base. So my exponential property of equality tells me I can now set my two exponents equal to each other. So then I have 2 times x, which is 2x equals 5. And then what do we do to solve for x here? Divide by what? By 2. So x is going to equal 5 halves. You can just leave it as a fraction. Okay? All right. All right, so please copy this one. We have 2 to the 6x is equal to 8 to the x plus 1. So it's going to get a little bit more complicated now. It's not that bad. It just looks scary, but it's not that scary. Okay. Remember, my goal is to get the b to the m equals b to the n power, so that then my exponents can equal each other, right? This is my goal. My gal. No, pues well. This is my goal, right? And then I need to know my exponent rules, which we'll kind of talk about in a little bit. So, can I get the 2? Can I get the 8 into a base of 2? 8, can I get it as a power of 2? Yes. 2 to the what power? Third. And then my 2, I'm just going to leave it. So I'm just going to copy that 2 to the 6x. equals. For 8, you guys said 2 to the third power? To the x plus 1. And we kind of already talked about it, but this was just like a x, so it just ended up being 3x. But what's the rule here for the exponent? My side note here, I'm going to write it out again. If this was x to the m raised to the n power, what do we do to the exponents? Multiply them, right? This is m times n. In all the previous examples, it didn't really matter because it was just an x, right? But this one you have to be careful because you have an x plus 1. That means I'm going to have to actually write it out differently, okay? So it's going to be base 2. So now I can just make the exponents equal. This is going to be 6x equals. For my second exponent there, that's 3 times x plus 1. So you want to put that in parentheses. 3 parentheses x plus 1. And that's very important for you to do it that way because then you guys have to distribute the 3, okay? If you don't put it like this, then you're going to end up with like just 3 times x and then a plus 1 on the outside. So make sure you put the parentheses to remind you to distribute, okay? So in this case, I need to take the 3 and then distribute. 3 times x is 3x and 3 times 1 is 3. So this is going to be 6x equals 3x plus 3. All right, then I need to solve for x. Notice I have 2 x's, one on each side, yes? So I first need to get the x's on one side and then the numbers on the other. So which x should we move, the 3x or the 6x? The 3x. Let's subtract 3x on each side. That's going to give us 6 minus 3 is 3x equals 3. And then what do we do after? Divide by 3. That gives us x is equal to 1. And that's my final answer. Okay? So it's not really that much different. It's just doing this extra step right here of distributing and then solving for x. All right, let's go ahead and look at another one with fractions. With this one, go ahead and copy this one. 9 to the x minus 4 is equal to 1 over 27 to the 2x plus 3. All right, so for this one, I have a 9. Can I put 27 as a base of 9? What's 9 squared? That's 81, right? So I can't get this into a base of 9. What's my other option then? 3. I want to do base of 3. Because I know that 3 squared is 9, and I know that 3 to the third power is 27, right? So both of them can be written as a base of 3. So then my 9 is going to be 3 to the what power again? Second, but then that's raised to the x minus 4 power. And then that's going to equal my 27 as a base of 3. Because it's a fraction, my exponent has to be what? Negative. And so that's going to be negative 3 to the 2x plus 3 power. Okay? And then again, now my bases are equal. Now my base of 3 are equal. So then I can take the exponents and make them equal to each other. But because it's a power to a power, we multiply, right? So this is going to be 2 times x minus 4 equals my negative 3 times 2x plus 3. And then we're going to have to distribute on each side. So take the 2 times x is 2x. 2 times negative 4 is negative 8. And then negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. And then we need to solve for x. I have x's on both sides and I have numbers on both sides. So you want to get the x's on one side, the numbers on the other. And I personally like to deal with positive x's. So which one can I move to make it positive x? The 6. We can add 6x on each side. And then that's going to give us, oops, I would put minus. What's 2x plus 6x? 8x minus 8 equals negative 9. And then what can we do after? Add 8, because you want the inverse. So we get 8x equals, what's negative 9 plus 8? Negative 1. And then I need to continue over here on this side. I ran out of room. So this is 8x equals negative 1. What do I do to get x by itself? Divide by 8. That gives us x is going to equal what? Negative 1 over 8. And that's my final answer. Okay. All right. We don't have very much time left, so we're going to just stop there. And I hate to give you guys homework over the weekend, but yeah. We'll just do more examples on Monday, and then we'll do the assignment in class on Monday. How about that? So I don't want you guys to do homework over the weekend, so no homework. We'll do more examples on Friday in class, and then on Monday in class, and then we'll just go from there.